Okay, students, so we're here and we're with the last part of the video. All right, so we're going to be doing stuff about graphing lines. So use the figure on the right to answer the follow-up questions given that the equation for the graph to the right is y equals 1/3 x plus 2. So before we even get started, we know we're doing things, so slope is 1/3 of this line. So what slope would be perpendicular to the line? Well, the slope's 1/3. Perpendicular, remember it's the opposite reciprocal. Which means change sign and flip. Okay? So m, if the slope is 1/3, that means it's going to be -3, and that's it. Technically -3/1, but just -3. All right, so that's the answer to part A. Part B says, would the line passing through points -1, 2 and -2, 5 be parallel, perpendicular, or neither to the given line? So we can use, there's a couple ways to do this. We can use the slope formula. We just subtract the y's. So y sub 2, we'll just do 2 minus 5 over -1 plus 2 because it's minus and negative. And we're going to get -3 over 1, which is -3. So it would be perpendicular. So we did it with the formula, or we could even graph it and just go -1, 2, which is right there, and then -2, 5, which is right there. And that's what the line would look like. Those lines are perpendicular. Again, what's so great about making perpendicular lines in a coordinate plane? Coordinate geometry, computer animation uses this stuff all the time. But furthermore, to emphasize things is then you would just count the slope from here. Down 3, right 1. All right, the rise, -3, run of just 1. All right. So you can graph it and count the slope. That's probably what I would do, but don't forget about the slope formula. Is the line for the equation y equals 3x plus 4 parallel, perpendicular, or neither to the given line? All right, this would be, this has a slope of 3. It's neither. All right, because remember, we didn't change the sign. In fact, if we want to look at what this would be, that's 3, right? Or excuse me, slope or y-intercept of 4, slope of 3. So 1, 2, 3 over 1. And we can just tell that purple line is neither. It intersects, but it's neither. All right. And then we already talked about this before. This is just kind of emphasizing things. This line also has a slope of -3, so it would be perpendicular to the given line. And in fact, let's graph this bad boy, because why not? All right. And then last, what we're going to do is we're going to draw a line parallel to the given line. That goes through -5, 4. So my parallel slope, my parallel m, will be 1/3. So all I got to do is plot -5, -4. So left 5, down 4. And then just go up 1 over 3, up 1 over 3. And that's it right there. All right, that's what it should look like. And then I need to go perpendicular. Again, we've used the slope a lot of times, but the perpendicular slope will be -3. So all I have to do is plot -2, 6. So it's getting pretty messy over here. 1, 2, up 6, right there. And then just do a slope of down 3 over 1, and that's what it would look like there. All right, got a little messy at the end. I'm sorry, but that's what it looks like. Okay, a lot of chaos going on in that one graph, but just a good little review of parallel slopes, perpendicular slopes. Remember, parallel slopes are the same. They're equal, perpendicular, opposite reciprocals. So this is a massive problem, and we're done. Okay? And then last problem of the review, a big long review. Line 1 and line 2 show whether line 1 and line 2 are parallel or not. All right? So this is what I'm going to do. I'm going to count entire, this word entire, super important, entire slope. All right, like looking at this line on the left. All right, I'm not sure what crosses what. Is it cross right here? I'm not really sure. To ensure that I get the most accurate slope, so let's call this line 1. We're gonna go up 1, 2, 3, 4, 5, 6, right 2. So slope, line 1, the slope is rise over run, up 6 over 2, which is 3. And then for line 2, again, count the entire slope. It looks like it crosses right here, but I'm not sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So rise 14 over 1, 2, 3, 4, 5. All right. So line 1, not parallel to line 2. Why? 3 does not equal 14 divided by 5. They're close, but they're not the exact equal numbers. So that's it. We're done with the Unit 3 review. Pretty good stuff. If you want, even watch the video again just to hear it. That way we can do as best as we can on the test and be glad we are done with the review.